Is it okay? Let's get started. So I'm supposed to cover two things this evening, and I kind of want to mix and match a bit. Uh, I think it's been long. We should start looking at the actual code, like actual palette code. So I want to start off with showing you executive system and some other palettes, and then show you how to use tokens in your assignment. Um, okay, let's do this. So there's no set like way that I want to do this. I want to kind of navigate with you guys. If you guys want to see some code or want to see some examples, I could try to go through that. It's too small, right? Okay. Do you guys all have Polkadot SDK in your local machine? I think it's very helpful to have it. Um, you'd probably find all examples of anything you want to do here. And I could navigate this structure a bit with you, try to show you some palettes, and hopefully then you will be ready to dive by yourself, go and look the code by yourself, find things. Okay. So there are three major directories that you see here. There is Polkadot, which is like runtimes that we have. Uh, the actual production runtimes are moved into another repository. It's like a fellowship repository controlled by a fellowship, not parity. But we do have like testnets that we run here. So if you look at Polkadot, runtime, and there are like two testnets, Rococo and Western. I think Rococo might have been deprecated. I'm not sure. Um, so I'm going to start with like the runtime, and I'm going to use West End as my reference. But there are a lot of runtimes. There is every palette has mock runtimes as well. So we will see a lot of these runtimes. So the first entry point probably you should see is construct runtime. Oh, a lot of palettes. So this is where we are declaring our runtime, bunch of attribute macros for our runtime struct, and then we start defining our palettes in this runtime. I think maybe Alex showed all this to you. But system is always 0. Let's see what are interesting palettes. There is Babe, which is like consensus. Balances. This is probably going to be useful to understand how to manage your tokens. Transaction payment. This is the guy who charges fees uh, when you submit extrinsic. There's staking. I will try to look over this as well. Grandpa is like the finality gadget of the Western runtime. This palette utility, somebody asked me if we can batch extrinsics together. So I'll show you an example of this. There's also a multisig. This is a stateless multisig, but we can look over, we can find some nice things from here. Yeah, I'm not very familiar, but I can totally look with you guys, referenda and treasury. Um, yeah, these are like the governance palettes that we have. There should be also conviction voting. Yeah. Yeah, the bunch of palettes. I can't cover all of them. All of them are its own rabbit hole. Okay, where should we start? Executive? Sorry? Balances? Not system or executive? Let's look a little bit of executive and then we can dive into palettes. So you could see there is this executive. So, okay, let's actually first look where are executive getting used. You remember something like this code? You have this impl runtime APIs block where you are implementing some runtime APIs that the node calls to do things, right? So your runtime needs to implement these things. And so you have execute block, initialize block, bunch of other things. There's some metadata related things. There's apply extrinsic, finalize block, right? So our frameless was a very naive implementation. This is basically also the frame implementation. And all these pieces that we saw in frameless is it's the executive that orchestrates them. Okay, let's look at, so, okay. So you see the runtimes. Runtimes are here. I guess if you have to pick and refer some runtime, I guess Western runtime is a good thing to look for. Let's look at other things in this. So there's the substrate directory, right? And this is where all your frame palettes are. Frame palettes, primitives, mostly everything that you will need. So in substrate, you have this frame, and this is just all the palettes that we have. Um, even executive is here. It's not exactly a palette. It will not have usual things that you see in the palette, but it's also inside frame. Yes, question. Off-chain worker?
Well, if you can go back to the code where there is a code for off-chain worker, so if you can elaborate a bit about it.
Off-chain worker. It was in the runtime, right? This one? How do I say? So off-chain workers are like, first of all, not consensus, right? It's like a parallel program that you ship with your node. So I'll give an example. So in Polkadot, we run an off-chain election of validators, how they get selected. So there is some nomination going on, and from that data, we do some kind of optimization and like choosing the best solution. And that part is off-chain. And we want every validator to do it. If we make an upgrade, we want every validator to upgrade with us. So what we do is the logic that you, like some logic that you want to ship that is extra than what substrate node would support, you can ship with the off-chain worker. And you can spawn off-chain worker. It does some things, and it can try to put a signed extrinsic, right? So yeah, that's all. But it's not consensus. like it cannot do some HTTP call and we can have consensus about it.
Yeah, this is where the work related to when we have the stage, like auditing stage, like where the nodes writing the finalized block, stuff like this. This is where, like I remember, like I think it was 3 days ago or so, where we are talking about the process, and there one of the step after the block is already like added to the relay chain, we have another like kind of sync in a synchronous way.
No.
Okay.
So that is on client side. It
It
does
is
all that.
offline, yeah.
From the runtime side, you don't care about like forks or finalization or stuff. You just think of, you're just creating a block. It's just one computer. And all these finalizing blocks and stuff is kind of on the client side.
Okay.
But off-chain worker, I mean, I could show you a little bit. At least one program that I know that we wrote. Yeah, like an election miner, we call it. Okay. Executive. So let's see if it has, like, let's go with initialize block. Okay. Okay, no. Yeah. Okay, it has some initialize block info. Okay. So what is it doing? It's the first thing it is doing is taking just system. Yeah. Initializing calling the system initialize hook. Then it's calling all pallets with system and on initialize on it with the block number. It's registering some extra weight unchecked. What else? Okay, maybe initialize block is not that fun. Maybe apply extrinsic. Okay.
What are you looking for?
Nothing, just going around. Let's see what happens in apply extrinsic. So we get the extrinsic. So I think this is like where we are importing the block. We get all the extrinsics, we apply, let's see what we do in apply. Yeah, okay. I think this is something interesting to show. We do some checks here. XT is, I think, unchecked transactions. I'm not wrong. Yeah. Yeah, okay. So this code looks a little bit like what we were doing in Frameless. Let's see. We apply, the first thing we do is apply some inherence. So have we talked about the inherence? Anybody knows what's inherence? So inherence is like unsigned extrinsics. It's the validator who's the author of a block. They can put some inherent. We are noting the extrinsic. We are doing, yeah.
Can I add something?
Yeah.
The distinction between unsigned transactions that someone could also send, and then the inherents are the ones as Ankan was saying, by the block producer. And there is a distinction, like the inherents are there by fiat of the block producer. And then there are unsigned transactions. They are also unsigned, but then there are other unsigned transactions that might even circulate through the pool of the different nodes and stuff. So they are unsigned, but there are different kinds of unsigned transactions, and the inherents have a special place because there is as part of consensus, there is an agreement that the block producer can and should put them there, which is not necessarily the case for other unsigned transactions. A different example for an unsigned transaction that is not this, not an inherent, is if you have a runtime upgrade, someone needs to provide the binary, the wasm blob for that runtime upgrade. And that, for example, if I remember correctly, that's an unsigned transaction. As soon as there is agreement on what the upgrade should be in terms of the hash of the wasm blob, anyone can contribute the wasm blob as an unsigned transaction without an origin, but it's not an inherent. So just wanted to make that distinction clear.
Yeah. Trying to find the code where we actually do transaction extension checks.
Actually, I just had one small question
Yeah.
before you continue. In other places in the code, there's an example where a function in a palette, it dispatches a call to another, whatever. It can dispatch, we can dispatch a call, right? Inside your frame palette logic.
Yeah.
Does this also count as an inherent because it's made by the block producer, right? He's the one calling new whatever palette runtime, whatever else function.
So you're talking about redispatching. So some palette call has happened and it's redispatching to another.
Yeah, it's redispatching.
Now you're in outside pre-dispatch phase. Now it's just directly dispatching to another palette.
Okay, so this is counted as part of the extrinsics runtime
it's
itself.
the same extrinsic.
Execution. Okay.
Yes.
Thank you.
We'll talk more about the transaction lifecycle in the lecture that is coming, I think, tomorrow.
So yeah, I mean, there's some code that I sometimes find and sometimes I don't find, but if you go and start looking at it, all the things that we did in Frameless, we are doing here. We are also doing this storage root checks and stuff. So yeah, you can look over it by yourself. Try to compare maybe Frameless and what we are doing here. Everything that we were implementing in Frameless, we'll be doing in Executive as well. Okay, let's look at balance. Let's go with system first, and then we will go with balances. System. So this is almost like every other palette. It should have some, let's see, should have some storage. Yeah. It has accounts.
Do you want to talk about
You can actually look at this syntax. So I think somebody was, I think you were looking at this, right? You were trying to create some storage map. You can start looking at these examples. And so here how we are defining the storage map. Same thing that I showed you in the frame storage syntax. All this is here. It has a count. It has extrinsic count. Yeah. So if you look at the storages, it kind of makes sense. It's not doing anything business logic. It is doing something related to more like core parts of your blockchain, how the blocks are produced, what extrinsics are there, what events are there. And this is also like so every other palette, and I will show you this, the config will extend from the frame system. It's a mandatory thing. I think your compiler will throw an error if you don't do that. Let's look at some calls. Do you know about remark? Can anybody tell me what this is doing?
remark allows you to submit just general text to the blockchain.
Yeah, it's like free text that you can put on the chain. You're not changing any storage. It's just in the history, some text that you remark it, right?
Wouldn't it still use up storage because it's in the state
Sorry.
forever?
Yes, it's. I don't know if you guys have known that there used to be a project Remark NFTs, which used to work totally on remarks. So basically, they created some kind of protocol on how the remark structure should be. Just put these remarks, and from this, they were like doing some state transition in a way. Sorry.
It was, I think it was December of last year. It was called dot ordinals, and there was a lot of activity on the relay chain because of it. But it just lasted for like 2 weeks.
Can I talk about the distinction that I think has come up a few times with storage? So there's two different kinds of storage, and here Remark I think is a good case where you see the distinction. There is the storage as the amount of memory or storage on disk that a validator or an archive node has to keep around, and then of course multiplied by the number of archive nodes and number of validators. This will include some amount of history of the chain. And so the remark is part of the history of the chain. And so the more history you keep around, of course, the more storage you need on that particular node. And so for an archive node, it's basically whatever happens in the runtime, there's always some way that it's part of the history, right? With the remark, it's just the extrinsic is part of the extrinsic root of that particular block, right? It's part of the Merkle tree, and it's there somehow. It's not stored in the actual storage as in the key value database of the current state of the blockchain. Because the extrinsics we saw, right, they're flushed because for the new block, for the next block, they're not relevant. So this remark it's flushed. It's not part of the current state. It's not put anywhere in storage compared to like an account transfer, right? The account transfer transfers tokens from one account to another within the storage of the chain, which means that the current state is changed. So the most recent state is changed, and it means that the most recent change, if I transfer to a new account will need to be created and will need to be kept around in the current state. So no matter how much history I keep, the current state includes that data. But other things like the remark are part of the history. So how much they impact the data requirements, the amount of storage I need, depends on how much history I keep around. If I have an archive node that keeps the whole history, they will be part of it. If I have a node, like a validator is only required to keep a subset of the history, if I remember correctly. It should be a few hundred blocks or something. So then for them, it will not be, right? As soon as the remark is out of that window that the validator needs to keep around, it's not part of the current state of the blockchain, so it's tossed aside. So there's this distinction between the history, like does something bloat the history of the chain versus does something bloat the current state of the chain? And I wanted to talk about that because it came up here.
Yeah, if you look at it, there is no storage access. It's just doing nothing. It's just whatever the remark. And another thing actually to look at, there is a pallet weight specified, and the weight kind of is a function of remark, the length of the remark. So depending on what is the length, you charge some weight. You do nothing, but as Alex said, by default, every node, if you run a substrate node, relay chain node, I think we keep a history of 256 blocks, but there are archive nodes which keep whole history. So you could look at all these remarks if you look at the blocks.
I was just going to say, it kind of looks like call data in Solidity, where you have like data that's like stored and maybe flushed. I guess this one seems like it could live longer than the actual function call.
I'm not familiar with it, but I'm guessing they also have something like this. Okay, look at this set code. So there's the extrinsic set code. It has to come with root privilege. It depends on something called onset code. And let's see what is onset code. Some trait. Ooh, my Rust rover is acting. But this is all. Somehow, something is sending this extrinsic with root privilege, and we can just update the code. And next time the block, for the next block, we will read the new Wasm code, start our executor, and basically our runtime is updated. Actually want to see if I can find.
The reason it's a callback, the set code, right, the trait, and it's a callback, is because there's this distinction here between parachains and standalone chains. Because for the parachain, right, we need to pass the code to the relay chain in order for it to change our code, because we don't directly control it. And then for a sovereign chain, we just set it directly. So there's a distinction there. It's configured differently for a parachain and a sovereign chain, I think.
Yeah, I can't navigate much because apparently my whole storage was filled with Rust target, and I had to clean everything, and now it's rebuilding. But it's okay. We can just navigate around. What else is interesting? You can already just look at few things and get some signals. So there is this thing of authorize upgrade, and probably this means you have to first authorize upgrade, then call upgrade. And if it's not authorized, it will fail somehow.
The apply authorized upgrade, I think, is the unsigned transaction I mentioned earlier.
Sorry?
Can you go to apply unauthorized? Yeah, there, no, below.
Oh.
There, apply authorized. I think it should check for none, like that it's origin none, I think. All origins are allowed. Yeah, but including none, I think.
So another thing to note, if you see all these calls, they have really nice documentation. So there is a good link that you can follow. So the Rust code for our Polkadot SDK, the Rust documentation is hosted at paritytech.github.io. And let's say this function, right? Authorize upgrade without checks. So you see that documentation here, right? So all these documentation that you write are very useful. Please write them nicely. Okay. Bunch of events. Anything else okay. Which palette should I go next?
Balances.
Balances?
Assets.
Actually, I would like to go and show you something else first and then move to balances, just quickly. Oh man, nothing is working. So staking is one of the palettes that uses, of course, tokens to hold, it also does reward stuff. I think for DPoS assignment, it probably is very useful. And I will show you a few things. Actually, they have a different structure, so that's mod. So it has this type, currency, fun hole, whatever, doesn't matter yet. So any palette that wants to work with balances, it does it via trades. It does not depend directly on palette balances. Palette balances is the one that probably we can already guess implement some trades, and other palettes can depend on just these trades. So you look, it depends on something called type currency, which extends some trades. And if I go back to my sorry, I hope my battery doesn't die. It's running on full power. Okay, what I wanted to show you, yeah. Let's look at the config of palette staking from runtime, what we are setting there. So palette staking config. You can ignore the old currency, some weird reasons. But type currency, we are providing an implementation of traits it wants. So you're just providing something, a palette, that implements that fun hold mutate that you saw, right? So your palette, if you're working with it, you will not need to directly depend on palette balances. You will use one or multiple these traits and use the APIs provided by those traits to do your stuff. Okay, with that said, I could actually show some slides. Okay, another thing before we actually go further. Do you guys know about existential deposit? How many of you know? Decent. Can anybody want to take a dig at why we need existential deposit?
Hello,
Actually,
Marcin
it's
here.
written.
So yeah, so existential deposit is to preserve our accounts, so they are in the state. They have some deposits, so they are not deleted from the state.
But why do we even need? We can. I think Ethereum does not enforce all this, right? Solana doesn't. So you can create account with whatever balance, right? Solana does. Okay. Okay.
So the reason this made sense to me is like because Solana kind of does that. Like you can create account names in Solana, but you have to deposit a small amount of SOL. They call it rent to be able to reserve the space
Yep.
on the history. So I'm thinking this is similar, where if you want to maintain the state, you have to put a little bit of dot in there to like maintain
Yeah.
the
So-
cost of keeping it there.
Yeah. So any account, any balance you create, this goes in your state, right? This goes in your database. This database gets larger and larger. The larger it is, the slower your storage access gets. So if imagine if you don't have any minimum balance you need to keep, people can create like millions of accounts, very low balance, and we have to keep them alive all the time. What ED provides is, okay, we will keep your account alive as long as you put some minimal balance for which we now will keep your account alive. We run your account. But if it goes below that account, below that balance, we will dust it. So that's the idea. It's in a way to protect against this state bloating that can happen. Okay, some terms that will be very important. So we call in frame the tokens as fungible. It's like how non-fungible is cannot be exchanged. Fungible is each unit can be interchanged, right? A quick note before we go further. Also, you will see this in a lot of palettes currently where we are not using fungible. We are using something called currency, reservable currency, lockable currency and stuff. These are legacy traits. There are reasons that we can go on. What were the reasons? Not super important, but don't use this. If we see this in your assignment, that's like a -1, right? Use the new traits. We will go through the new traits that you can use, some APIs, so you get a feel of how you can use it. Don't use currency, reservable currency, lockable currency, related traits. Okay. Yeah. Okay. The balance, user balance, you can think of how it's like segregated. It's in two buckets. There's a free balance component and there's a held balance component. When you add these two, that is your total balance, but they are like in different buckets. They're exclusive. I put a formula of how much money you can spend. Honestly, this is a very tricky, and sometimes this is actually not true. You can know, but basically I will actually show you. Okay, I introduced few more words here: frozen, reserve, lot of lot of confusing terminology. Do I have a slide on these terms? No. Okay. How do I do this? Okay. This part is very confusing. It took me a while to get around it. You might see reserve word in many places. When you see reserve, think of it as holds. Okay? Just think of it as holds. When you see frozen, and you will see here another term, lock. Lock was the old word, but we will be thrown around these words. So lock and frozen is one. I should write it somewhere so you guys remember. Lock and frozen are same thing. Reserved and held are same thing.
In theory, they're a different thing, and the holds and freezes are the new thing, and there are some differences.
Yes.
But we will use terms locks and reserves as well.
Yeah, so the implementation is different, but the thing is, if you look at the storage, how we store it, if you do a hold, it actually puts in something called reserved in the account info. So that's the confusing part. I could show these things. Let's do it. Let's pick up some address from subscan. Have you guys already used Polka.js? Pretty good tool, pretty fun. And remind me also to show you why it's in system and not in balances. Okay, this has.
Should be in the asset hub, no?
Did I pick? This was Polkadot. No. Maybe transferred everything. It has the accounts. Yes. Yeah, let's pick this. So, oh, wow. So when you query someone's balance in Polkadot, you will see these things.
Can you zoom a
it's
bit?
too broad. Sorry, what did you say?
Can you zoom? Make it bigger.
Yeah. Okay, so what is the core account info that we store for users? There's some nonce, some consumers and providers. We'll touch a little bit on what they are. Sufficiency, legacy, you can ignore it. And then there is some data, some free balance, some reserved balance. And this is what I was talking about, and frozen, right? So free is free, reserved or holds are kind of same. Not kind of same. In this case, they are totally same. Holds, when you hold, it gets added to, it gets removed from free and added to reserved. There is frozen, and you guys can correct me if I'm wrong, but the way my mental model is, what frozen does is it makes your account not go below some balance. So it puts some restriction that your total balance cannot go below this amount. That's all it does. The formulas are crazy. It's hard to make sense of, but just think of, okay, you can think of ED as like one dot, we have existential deposit. That's like a default frozen kind of thing. And you can extend it for some reason. I don't know, for voting, people are voting, so you don't allow anybody to go below some balance because they have voted and it's locked for a while. And this guy has reserve. So let's actually look, where is this reserve? So this is like the meta storage where we keep these values, but then the holds that we do are named. And the problem is this reserve maybe is coming from an older trade, that currency trade, which are not named. So that could be a problem, but let's check if they are. So look at, yeah, they have. Perfect. So I looked at balances, hold, and they have, it's a array. It has one hold right now with some name, staking, and some value. And if you see, this value is same as reserve, right? So let's now go back to our slides. Any questions yet? Yeah, okay.
I have two questions. Can you hear me now? Yeah. The first one for the balance trade and how like the frozen and reserved things. Is it only for DOT or any token? Like if it's only for DOT, how we can manage our own token?
So this is the native token of your chain.
Yeah.
Okay. When you create your own runtime, you can have your own
So
native
like,
token.
it is by default, like in my parachain, it has to be like this. If I want to customize, I need to kind of override.
You could create you could have multiple assets. So there is, I will show you fungible trade, which supports one asset. There is also fungible trade that I will not go through, but they have almost similar API where you can manage multiple assets.
Okay.
Okay.
The second question, because I remember I asked this question before, like when this part was explained. The more transaction you are doing, the more money you have to add to your account. It's kind of frozen or whatever we call it, for renting your storage. Is that correct?
The more money you put, the more.
Not the more money. Like it's like I want to stake. I want to vote. I want to do kind of multiple transactions. So it's kind of like the rent is like actually. I have to increase the amount of money frozen to support the transaction I'm making because I'm making more transaction. Similar to like what is in here, for example, like the storage amount you're putting in your storage, and it gives you like the ability to do more transaction, and you need to keep the amount staked or the amount frozen within a certain threshold.
Yeah, I mean, yeah, as long as you want to do more and more things, you might need more and more funds. Holds and freezes basically exist because we want people to vote with staked funds. Like that's basically the reason why we have holds and freezes. So hold is basically what you use for staking or what you use for storage deposits. So whenever you put something in storage, you need to put a storage deposit, and that's almost always handled with a hold. And freezes exist so that because you can freeze a hold. So if you have a storage deposit, or if you're staking, you can still use those funds for voting, because voting uses freezes. So that's like the key features. You can you can overlap freezes with holds. So as if you stake, you get a hold. If you vote, you get a freeze. And yeah, that's pretty much it.
What the part which like confuse me or like I'm concerned about is like if we like the user has to increase their holds based on the number of transactions they are making. How can I, as a developer, make sure that whenever he is doing kind of transaction, the math part related to the making sure that like the weight. I feel like there is something I misunderstood. That's why I'm raising this.
So you don't need to keep track of anything. So that's why we have these APIs. So these APIs work for any token. So any token, this concept of holding it or freezing it, we kind of like provide to you with these APIs. It can be your native token or any token you want. And you don't need to keep track of all these things. They will be kept as long as you use the right APIs. Like you use some functions that will make sure that the amount held is less than the total amount and all those things.
Yeah, let's go through the slides. I think a lot of your questions will hopefully get answered. So, okay, now we know there's hold and freezes. When should you use holds? When should you use freezes? So the thing with holds is they stack up. If your pallet 1 does some hold and pallet 2 does some hold, they're exclusive, right? They are both taken away from free. They are both separate. They stack on top of each other. Freezes overlap. So first pallet does freeze of 100 dot. Second does for 200. Third does for 150. Can you guess how much would be the total frozen right now? 200.
I wonder whether it's useful to analogize with read and write locks. It doesn't quite work because you can do a freeze on a hold and you can't do a read lock on a write lock. But
what is the last part you said?
so it's a very flawed analogy, but I wonder whether it would be helpful. So so I'm just going to give it. So you could think of the freeze as a read lock. You can have many read locks on the same file, right? So you can have many freezes on the same account balance, but you can only have on the same amount of balance, you can have only one hold, so only one write lock. So it's a bit like a write lock. But it doesn't quite work in the sense that you can have a freeze, which would be a read lock, over a combined balance of a hold and free balance. So it doesn't quite work.
So the way I think is every pallet is saying, don't let this account's balance go below this amount, right? And whatever they said, if it's if the total balance is higher than that, we are fine.
Yeah, so I would think of this as holds. What I really like about the slides is what you use them for. I think they pretty much sum up like their differences. So holds is basically staking and freezes is basically voting. Like if you think about how they came to be, which I think it's because of that, or to allow staking funds to vote, then I think you can figure out which one to use.
Yeah, vesting is also pretty good use case where you don't want someone to spend their balance, but you don't want to hold them. They can use that balance to do other things, probably. So yeah. There is actually one case where I think in nomination pool, which is like extension of staking, we do have higher balance requirement because we want some account to be provided by some provider, which should maintain some minimum balance. And so that's also, so if you want to increase the ED in a way, That's also one way. You freeze like 2 dots and you say now it's kind of your new ED is 2 dot, right? Just in like mental model, not exactly. ED is separate thing. Okay.
And an additional thing from the last slide, holds are slashable and freezes are not. That's another crucial difference. Like that's why staking uses holds, because holds are taken from your balance. They're basically someone else is holding your money in a way, and they can slash it. So stake, it can be slashed when you're staking, or you put some sort of collateral for whatever DeFi or some other thing. And freeze is more like a proof that you have funds. Like when you want to vote, all you need to prove is that you have enough funds. And then you freeze them, you cannot use them for the duration of the referendum. And we need that to be civil resistant. Like you cannot vote if you don't have funds, because else you'll be able to create like 1 million accounts and vote with all of them. So that's kind of the differences there.
Yeah.
Is it what? Yeah,
Okay. Right. Why can we have a freeze on a hold balance?
Sorry, what was the question?
So he asks, why can we freeze held balance?
We can actually.
Yeah, wait.
So
You-
the
you asked
frozen-
why we can or why we can't?
So
Yeah, okay. Yeah, you can answer, yeah. It's
So-
why
so-
we can.
So when I'm saying that frozen puts a condition that your balance cannot drop, not the free balance, the total balance. It's saying the total balance cannot drop below this value.
Yeah, my reasoning is like, the reason why we did holds and freezes is so that you can stake. And with the, let's say you stake 500 dot, right? You should be able to vote as well with those 500 dot. So we created a system where there are 2 types of locks that you can put into some funds. You can either hold funds or freeze funds. And this can overlap. So when you vote, your funds are frozen. That means that is a type of lock. So you cannot move those funds away. You cannot transfer them to someone else. But when you stake, they are held, which is another type of lock. You cannot transfer them away either. But because freezes and holds can overlap, you can stake and vote with your staked tokens.
Yeah.
Same with vesting. Can you stake vesting? Yeah. So, for example, you receive some. So it's very beneficial to have multiple types of locks, not just the one generic lock that you just cannot do anything with that money. So let's say you receive some funds, but they're vested over 2 years. Like someone gave you some money, but it will unlock over time, right? You cannot use it now. You will be able to use it in the future. You can still stake that amount because it's a freeze, like vesting is a freeze, but staking is a hold. So it's very useful to have these 2 separate types of locks. I hope that answers a little bit.
If someone needs you to keep that money, and someone needs to slash you, how would that work?
You can answer that one if you want.
If somebody wants to, can you rephrase it?
Yeah, so like holds are slashable, but freezes are not. So if you're staking, I can slash your stake. And then it doesn't matter if you have a freeze, because a freeze just says that your money cannot go below a certain amount. If you're slashed, then
Yeah, this stacking thing also makes sense because imagine for voting, why would you slash your votes? It's just a log that you should not spend until some time, right? To actually make some funds slashable, you need to reserve it somehow. You need to keep it away from the free balance. That is liable for slashing at some point.
Okay, I just want to, over here, before we go too far, right? She asked a question that I feel was not properly addressed, right? She said that, we have an existential deposit. Well, correct me if I'm wrong, maybe I didn't get that question right. So she was asking that this existential deposit, right, would it increase based on the number of transactions people do, right? So there's essential deposit on Polkadot's relay chain currently is, I don't know, is it
One
two
dot.
dots? One dot,
Yeah.
right? Okay, so let's assume all the pallets have not been migrated to Asset Hub, right? If I transact with 100 different accounts, I send 100 different transactions, right? Would my existential deposits increase?
Why should it increase? Are you taking more storage? Let's think like that. Let's think from first principles.
Exactly.
But when should we increase that balance? If we are now taking more storage, if somehow they are, doing something that makes us put some extra storage, right?
Yeah, exactly. So in my experience, it doesn't increase, right? Because
Yeah.
I've been using Polkadot for a while, right? But I feel like the kind of answer she got would make her think it increases. I don't know if she got that impression.
Yeah.
I got like it's like incorrect. It's in the
I think he added a great point that it's like renting for storage. And if you're so imagine somebody's staking, then we create bunch of more storage for them. Now staking maybe will be like, oh, we need minimum bond. You cannot just stake whatever 0.1, right? We need to have minimum hold for which, it's after which point it's okay. We can keep your storage forever, right? So then it's other pallets that will do it. Just for your account, it's the ED is just for keeping your account alive, which is one dot. And that by doing more transaction, that does not change the storage. It just changes the value in the same storage, right?
yes, right. I have like one question or two questions, like kind of like
Okay.
related to each other. For the frozen dots here, it's on the slide here. It's not slashable. So my question, or my first question is like, it's impossible to be slashed.
I think there is a way to slash. So if you have system privilege access, and if staking wants to slash someone, and for whatever reason it doesn't have enough hold funds to do it, then it can go over and slash. But I think these are very edge cases and probably will never happen.
The reason why I'm asking this question, and the second one is because I raised kind of like a question, kind of a security concern about kind of attack vector in voting, because there is like in the lecture where we're like got an introduction about voting things, there is a way to maximize your weight, voting weight. And I said like it could be like misused in terms of like I can like maximize, and then any kind of vote I want to kind of give it a push to succeed. So after the lecture, I was sort of like, yeah, but there is a way if we, the community, think that, or the it's called the governance things. I forgot the name of the entity or the group managing this. Said like, yeah, but they can in a way slash it. So if you are caught kind of misbehaving or kind of utilizing the governance in a way that, like, for example, I got money and then from the DAO and then from the treasury, and then I kind of like, instead of spending the money in a boot camp like this, I'm spending the money for whatever.
Yeah, so that wouldn't be called the slashing in like a technical sense. Like we usually call slashing like some staked funds get slashed, which you could actually have a situation which we don't do in OpenGov. In OpenGov, we just give you the money and ask no questions. But we could have a situation where we just put the money, some amount on hold, and there wouldn't be slashing, or maybe we take it away from you. But if governance knows that a particular account is malicious and like is doing whatever they want with their funds, they can of course like put a lock in it, remove it. They can do whatever they want. So because governance is basically root, so they can do whatever they want. This distinction between like holds can be slashed and freezes cannot be slashed is just like you can use as a developer the slashing API. It's not like they are untouchable by anyone. Like governance or root basically can always do everything they want. Like they could even kill the chain, like set code to nothing. So you can do whatever you want. but this is about the APIs. You can have like :/ on holds, but you cannot do so with freezes.
Okay, my second question is also related to this part, but imagine a situation where I'm a developer and I have a DAO. I like it's by default enabled. Like if I'm staking, I can utilize the stake to vote. And what if this account, after like he gave like kind of like a vote for this, and it's like frozen because he kind of like maximize his weight for the voting, he got slashed.
I believe he still voted, and the vote wouldn't be taken away from him.
You would just not be able to do more votes in the future, I think.
Okay, shall we move on? I can show you some few more examples just to better understand what is happening. Let's say you have 100 dots. I'm taking this actually from the wiki link and it's in speaker notes. So yeah, you can go and check it. You have 100 dots, out of which 99 is spendable because 1 dot is the existential deposit. It's a little bit tricky to say what is spendable because technically you can spend all 100 and let your account die, right? But if it's spent, 99 is spendable in a way that you want to keep your account alive. Let's say we stake 60 dots. What happens then? 60 dot is reserved, 40 is free, but out of 1 that is ED, so 39 is your spendable. Now we created a proxy, and for proxy, we do a deposit of 20 dots. So now 60 dot staking is reserved, 20 dot proxy deposit. So your 80 dot is held now. It went from the free to the reserved bucket, right? Your free is 20 dot, out of which 1 is ED. One interesting thing that probably I didn't, or I don't know if I made it clear enough, so if you look at this, these values, let's say this account did some reserve, 100 dot of, it does, sorry, not reserve. It wants to, it has to have, 100 dot has to be frozen, right? It will not go away from free. So frozen is like just a number, and a number which basically is saying, okay, the balance should not go below this, but it is still part of the free bucket. So it acts a little bit differently than reserved, which basically is a separate exclusive bucket. Okay. Next, we did 20 dot of voting. This is interesting. This probably is useful to know. So 80 dots were reserved. 20 dot is frozen. But the 20 dot is still free because this 20 dot that is frozen overlaps with the held balance. Account votes on another governance proposal with 85 dots. So before it did 20 dots, now it's doing 85 dots. They will also overlap, so now the total frozen should be 85 dots. So 5 dots from free is now frozen. Only 15 dot is free, out of which 1 is ED, so 14 dot is spendable. Oh.
No, ED can be frozen. The ED is frozen and it's fine.
Ah, right, yeah. Good point. So 15 dot is spendable. Even the ED is part of the frozen balance. Yeah. That's it. Feel free to look into this. I think this will clarify how this fungible and this hold and frozen thing works. let's go back to our slides. Yeah, you might actually need to use this. So you might have a case where your pallet needs to have a pot account, as in account that belongs to that pallet. It somehow generated, it's like a keyless account that only your pallet manages. And for this account, you don't want it to die. You want it to stay alive, doesn't matter what is the balance. So there is this concept of providers and consumers. When something, so let me see if I'm saying the right thing. So when something is the reason why some account should be alive, that's like a provider. So when you put a balance that is more than one dot, the provider count is increasing. If you remember this here, it has one provider. It's coming from because they have some balance, right? Some balance that is above ED. A consumer is some pallet that depends on this account being alive. So as long as the consumer is not zero, you cannot kill the account. You don't need to worry about it too much. You might come across these, so I wanted to just tell you a little bit about what is provider. But there might be cases in your pallet where, again, you want your account to be, your pallet pot account to be alive. And what you can do is you can explicitly increase the provider on it, and that will make your account alive always. Doesn't matter if it's lower than one dot. Okay, all good now? We are now going to see the traits that we can use. Do I have the links? Yeah, something.
A little more, I would say. Zoom a little more.
Okay, the first trait we will look at is, okay, so forget about holds and reserves. Maybe a holds, I'm sorry, frozen. The first thing you need to do is maybe you just need to interact with balances somehow. You need to check how much balance some user has. You just, yeah. Yeah. Let's just, so basically, okay, how do I say this? The way the traits are organized to play with the balances is in multiple, like, multiple layers with different privilege levels. So there is inspect, where you can only read the balance. You can see how much balance some account has, how much is the minimum balance, how much is active issuance. You can check someone's account. You can check how much money this account can spend. This reducible balance is like how much money they can spend given some condition. Do we want to preserve the account? Should we use what kind of privilege levels we should use in order to deduct some money? So this inspect trait allows you, just to read balances, do nothing else, right? Now maybe your palette wants to also mutate the balance somehow. So let's look at So what does mutate do? It can mint some balance into some account. Again, these are very dangerous functions. Be sure what you're doing, but your chain can have logic of some inflation, right? Based on, I don't know, you want to reward your validators every some period. So you will want to mint something, some balance, some rewards, right? Or you can have a deflationary economics, it's up to you. But there is a way to mint some amount, some account, right? There's a way to burn what shelf? Oh, so you can decrease the balance from some account, which is, okay, explain bonds. Yeah, I don't think this is even used much. It kind of makes it unactivated. But you can read the documentation if it helps your case. There is something called restore. Interesting one, transfer. So when your palette, it's like type native currency, and you're saying that native currency should extend from a trait, should be something that implements the trait mutate. You can use that to do transfers, which basically mutates some balance, right? You can set balance. I think this probably should only be used for tests. Yeah, it says good for use in tests. So in your test, you wanna, I don't know, put some balance, do some things, make sure everything passes. Yeah. So to recap, if your palette just wants to read some balance, not do anything else like mutation of any balance, you just depend on inspect rate. If you want to mutate, you use mutate rate, and I think, yeah, this extends inspect. So if you do mutate, it can also access the inspect APIs. Similarly, you have other traits for holding and for freezing. So you have something called inspect hold that comes from fungible library. Let's see. All these links are, I have linked this in the speaker notes, so you could see by yourself. So what does inspect hold allows you to do? You can check total balance on hold, how much balance you can take out from free to make a hold. Is there a hold for this account? Ensure it can hold, so it will give an error if you try to send up on, so it's like a dry run of whether you can hold something. Does not mutate. This is inspect rate, does not mutate. It just kind of dry runs. You can hold it. Sorry, yeah?
Zoom.
Ah, sorry. Yeah. Then, and I will go and show you some palettes where we use this. But now you can already guess what would be the mutate. It has some APIs like hold. It needs some reason. Again, we'll look at the live code, so you will know more about this. There's a way to release some hold held tokens. There's a way to set on hold, which basically just updates the value. It does not add to it, it just updates it. There's a release all where you're like, yeah, whatever hold, just release. Notice that there's a reason in almost all of these APIs, which means when you do release all, you are releasing only for some named reason. What is the named reason? So every palette who wants to do a hold can put one or many reasons. And so for every hold that you will do, you will say, okay, this hold is for this reason, right? And you only update based on that reason. You cannot go and update some other reasons hold. You can burn held. This is like slashing. Burn all held. You could also transfer on hold. This actually I used somewhere in some migration where there is some funds held on some account. You want to transfer it, but keep the hold on the other account now. So you can do this. Transfer and hold. Yeah. Any questions? Is it clear like how or what you will use? We will also look at palettes, so it will get clearer, but do you feel like you have better understanding of what is hold, what is freeze, how will you use it maybe in your assignments? Yeah, this will.
It might be kind of dummy question, but uh, this this code is like all the dispatchable function is publicly available for anyone to inject from outside.
All dispatchable function.
Like the dispatchable function, like it's by default.
The call function.
Like the one
What slide are you looking at?
was like the way I understand, like if it has like a return curve dispatchable result, a dispatch result, it means like it's dispatchable function is correct.
I'm not sure if I get it. Do you guys get it?
So you're not wondering about these traits, right? About mutate hold?
Yeah, I mean like I'm checking all the file where we have so many functions. Some of them, it's not like it's kind of private, so like it's only like the visibility is only I think it's within the crate itself. Is it correct?
So if it is part of the call, pallet call, then it's available. Otherwise, it's not to end users of the blockchain. And then the visibility within the runtime depends on the Rust module visibility. So if it's private or pub crate or public, like that will determine whether it's visible to other pallets.
I got where exactly I am confused. How can I know this function is dispatchable and it could be called from outside by the end user? Yeah, as simple as this.
Yeah, if it's tagged with pallet call. And
Only
it might
pallet
not
call.
it might not be the function itself, it might be the impl block that it's part of.
Okay.
Yeah, but only if it's tagged as pallet call.
Thank you.
Was this somehow related to this or something just?
It is because this file would help a lot, I think, in our assignment. And I was confused by the types, thinking that these kind of like function could be called from outside, so I cannot use any to
We will
override.
see. We will see how you can use this in
Okay,
the
thank
pattern.
you.
Yeah, but these traits are like things for the frame developer. So it's not that like they're not immediately available to people submitting an extrinsic. Like they're not an extrinsic. They're things you can use in your extrinsics or in any part of your code. It's for frame developers.
So these are internal libraries, right? You can use this, which are already implemented for you. You could potentially implement your own palette balances that has your own traits and do your own things. It's possible. It's kind of pointless at this point to do that, but you could. I mean, for your assignments, polls and freezes should be enough. If it's not enough, that's a great thing for you to give us the feedback and think of what is missing. Okay, let's look at a little bit of pseudocode, and then we will also look at some palette also where this thing is happening. In order to have a hold, you need a hold reason. And yeah, I don't know if you have seen this attribute macro, composite enum. It basically combines hold reason across palettes and again creates this runtime hold reason, like how you saw runtime call, runtime events. This also composites all the hold reason, creates this one big runtime hold reason. And you give some enum variant, this will be your reason for the hold. And so for every palette, everything, it's always unique. You cannot have collision and hold reason. Yeah, I can show this, but honestly, I think you get the drift. There's also inspect freeze and mutate freeze, similar to inspect hold and mutate hold. I've seen very few cases where freeze is used. So I don't know. There is a palette where I've used frozen, so I could show you that. But yeah, there must be some cases. I mean, voting is definitely there, but voting palette right now uses the old currency trait. That's sad. But yeah, if you are doing something similar, if you look at some palettes that is similar to what assignment you want to do, and if you see they're using currency, still don't use it. Try to use fungible. It should be easy to use it. It should not be a problem, but we are here to help you. We don't want to see that you using currency in your assignment. Okay. Let's see some code. Oh, sorry.
Is fungible being used in
Sorry.
production or just on the test net?
Say it again.
Is the fungible palette being used in production or just in test net?
Fungible is not a palette. It's
Oh.
a set of traits that's
Okay.
implemented by palette balances. It is in production as well,
Okay.
but
Thanks.
it's mixed right now. So there is this old legacy currency traits, which kind of does the similar thing, but has some things that were not really good, the way we were handling it. So fungible is the new way. And right now we're in a mixed state where some palettes use the old trait, some use the new traits. We want you guys to use the new trait.
Yeah, I think the data team still indexes on currency. So I'm just wondering if we're missing something by not looking at fungibles. So,
Fungible is used in production as well in
okay.
a lot of other palettes.
Can you give us more like info about the credit mentioned in the file, like regular.rs file? Like I see like
Which file?
it is regular.rs inside the fungible folder.
I don't get it.
Yeah.
Yeah, it's in the frame support, traits, tokens,
Ah, you want to see
fungible,
where
regular.rs.
Where
Yeah.
these traits are. Okay.
Yeah, where the traits are, and there's
So-
a regular, hold, and a freeze.
So let's
It's
look at
regular.
it. So frame has this, there should be a support somewhere. Right? Inside support. By the way, this procedural has all the macros that we use everywhere. Let's see here. There should be token. Yeah, traits, tokens, fungible. You see, there's a fungibles. Not covering that, but you can totally imagine it's almost exact same APIs with maybe one extra parameter, which is asset ID, but it's almost same. You will have fungibles, mutate hold, fungibles, inspect hold, fungibles, mutate freeze. So you could use, if you want multiple assets in your runtime, you can do that. Fungible, let's see. Now inside that you have regular, and I think this will have your normal inspect and mutate traits. Then you have hold, which also has inspect and mutate traits. You have freeze, and all these are re-exported, I think, if we look mutate hold maybe. Yeah, so it's re-exporting the hold inspect as mutate hold. It's kind of renaming it and redirecting it, right? But basically all this states all the state definitions you can find it here. Do you want to look at something else or?
What is the credit like? Because like mentioned in the comment, like converting the dust, which I believe is like kind of like a fractional, tiny fractionals into credit. What is credit here in this context?
Are you talking about slash or something else?
No, it's just like you can go to the line 118, if I'm not sure, mistaken.
Of the regular file, it was
The regular file. Just like what is credit here? Like
Yeah. Okay.
Yeah, so this
Excellent.
is very like into the weeds. So when these traits were defined, like you don't need, so as a developer, you don't need to worry about this credit thing too much, like, or actually at all, like most of the time. So you use the APIs, like the high level APIs. Most of the times, like you use in tests, you use like mint into and burn from, like when you want to like give some funds to someone or take them from them. And then you use like transfer when you want to move a balance to see the balance. Like you will use inspect and mutate all the time. But inspect and mutate are implemented based on some other low-level traits, which you're not expected to use. But the low-level traits deal with like credit and imbalances. So when you remove funds from a user, there's an imbalance between the total supply and like you can burn funds from someone and not update the total supply. That's an imbalance. You need to resolve that imbalance in some way. So the unbalanced trade, which you will find in there in case you're curious, will have ways of dealing with these imbalances. So you have debit when you take from someone, credit when you create something, and the ways of dealing with imbalances can be to remove it from the total supply or to send it to another account, for example, to the treasury account, right? But these are all low-level APIs. You are expected to use the high-level APIs, which are inspect and mutate, which are very simple to use, and they have only like 5 or 4 functions each, also for holds and freezes. And yeah, it's that. It's a high-level library for you to handle any type of asset.
Yeah, one example I could give in pallet staking, if your pallet does some hold, right, and can slash it. When you slash it, it creates an imbalance. So system is in credit. And now this credit, either you can drop it, or in slashing what we have is part of it, I think, goes to treasury. You could say credit. Yeah, I don't know exactly the terminologies we use, but you say where should the credit go, and you stitch in the treasury palette somehow that implements something that consumes a credit, and so part of the slash can go and credit the treasury, right? So yeah, it's all low-level thing. You probably don't need to use it, but probably good to know. Where was I? I wanted to show you whole reason stuff. Okay, let's go to. By the way, you will see the staking and staking async. Don't get confused. Probably staking async is the newer version, but staking is very complicated palette. You might get some good things, but TLDR, it's like we forked the staking palette because of some reasons. We are kind of moving the palette to another chain. Fun story, maybe in some other office hour. So yeah, staking async is the latest fork, and just staking is like the old thing. But I can look at this and go to source. Also, its structure is a little bit different. So I will show you other palettes, so hopefully you don't get confused. But this palette breaks down stuff too much, and not exactly the structure as you will see in other palettes. Don't follow this structure. I'll show you other palettes, and probably those are better ways to structure your palette code. But this does some hold. So let's see what you need to make a hold. So there should be like a runtime hold reason. So what kind of currency in your assignment template? It's called native currency, I think. Native balance. And this fun hold mutate has some associated types that you need to mix and match. You need to say the reason in this type comes from this runtime hold reason, which is on the runtime level. This is the composite enum that we created. Balance comes from somewhere else. Basically, this palette has currency balance directly defined. This is also not usual practice. But let's see. Okay, so we did this. You will probably also need to do this if you do hold mutate. What else? We need to define our hold reason. There should be an enum hold reason. You saw this syntax already. Pretty simple. And somewhere we should be also doing something like the currency hold. Set on hold. So how do we do it? We do some balance we are trying to hold. We are giving it a reason. We are doing this into, which means it's converting it into runtime hold reason. You're saying the balance, we're saying the amount. That's it. Think somewhere we release all, yeah? So this is two things it does. It does set on hold, it does release all. And let's see this release all. So release all has a reason, who, and there's a precision. So what's precision? Let's look at the top. If precision is best effort, then the amount unreserved and returned as the inner value of OK may be smaller than the amount passed. So what it is saying is precision can be multiple types, exact or best effort. I'm guessing if you put exact, it will fail if it's not able to release all. If you say best effort, it will try to release as much as it can, else it cannot. And why? I mean, in most cases, it will be able to do it, right? Why would you not be able to release what you have held? But it could be like it was slashed, some record was not updated, few edge cases when the code gets complex. I mean, these things can happen. I don't expect your code to have that, but it's good to know that there are these ways. I think probably for you, yeah, I should not say that, but probably exact will work for you guys always.
Probably depends on whether slashing is involved or not.
Yeah, but when you slash, you should update your other storage as well. So, I mean, for complex functions and all, I can see maybe these edge cases happen. For a smaller project, I guess that should not happen, but yeah, take it with a grain of salt. Maybe you're doing something very clever. Yeah, what else we do? We do slashing, I think, right? Slash burn health. Okay. Sorry? Oh, break time. What is the break time? 3 p.m. Okay, sorry. We can take a break. Yeah, I already showed you the code of runtime hold. Is there something you think is missing? Yeah. Is there something you think, do you feel confident about runtime hold, about trying to figure out by yourself and how to use it? Or would you like to see more examples? There is another thing, something called consideration that I want to cover. And then if we have time, I can maybe look at one more palette. No? Okay, let's move forward. So there is a new trait, consideration, and it kind of abstracts even the hold and the freeze part. So what you basically do is you say you have some, so the palette needs to is creating some storage for the account, right? And for that, based on the storage size, based on the kind of formula you choose, how based on the storage, proof size and compute, how you want to convert it into fee, it creates this this either hold or freeze depending on what you want in the code. So let's look at the example and you'll see more. Yeah. Okay, let's look at the definition. Some sort of cost taken from account temporarily in order to offset the cost to the chain of holding some data footprint in state. So what is footprint? Some footprint will convert into some cost. Right? So what is footprint? Number of blobs, the number of items that you're putting in state, and the size of blobs. In all the code that I saw, the number of blobs was always one, so I'm not sure which cases there will be more blobs, but just show you that there is this option of increasing the weight based on increasing the consideration fee based on the number of blobs. So, and how do you do it? So you have Frame already provides you two implementation. There's a linear storage price and constant storage price. Constant storage price does not increase based on increased footprint. Linear storage price increases with increased footprint. Yeah, let's look at the code. Maybe did I? What? Where is code?
These are the configurations that we want you to think about. So that's why we constrain this such as functions.
Pre-image. Okay, let's look at this.
If you try to do too much, we will
So there is this pre-image palette, which basically takes some blob and something that you can refer later for another palette. So it has this type consideration, extends from consideration. Let's see what is consideration. It's a trait which has few functions: new, update, drop, burn. I don't know what burn does, but I'll look at new, update, and drop. So the idea is your palette depends on some kind of consideration. What is this type of consideration is kind of set from the runtime level. So your palette level requirements are very generalized. You define some kind of footprint, and then what you do is consideration, new, it will give you a ticket, something back, some object back. You keep this in memory. You might want to update this ticket. So you will say, oh, now the new footprint is something else. That will destroy the old ticket, create a new ticket, give you that back, or you can drop it. And all the hold and freeze things that you saw, like, you set hold, you release hold, you put some reason, all these are abstracted. What you do is new, update, drop, and internally all these things are taken care for you. So let's look at how it's used here. So it's consideration. Okay, actually before this, we should look at how it is set from the runtime, right? So this palette just expects this type to implement this rate consideration. It doesn't know it's hold, it's frozen, how it should increase with footprint, but it has something called footprint. Let's see what is that. Yeah, so footprint is the struct which has number of blobs and total size of the blob in bytes. And now if I look at type consideration for pre-image, so at the runtime level, is this? Yeah. At the runtime level, you're saying, okay, this consideration should be hold consideration. It should have some hold reason. It should have a linear storage price. It has some kind of numbers from which this price is calculated. So there's a base deposit, there's a byte deposit. So let's look at this linear storage. What's doing it? Taking three things, base, slope, and balance, and it's using that somehow to convert the size and the number of blobs into some number. That is the storage fee that you should charge for using the state, right? Is it clear how it is using? So at palette level, it's generalized. On runtime level, you actually said you could have set something like freeze consideration. The palette does not care about it. It's on the runtime level that you said that what kind of hold or freeze, like which type of, what's the general word for it? But what do you want? Either you want hold or frozen. And even the whole reason, before we defined it on the palette level, but now we are defining it on the runtime level. Actually, okay, the whole reason is actually defined inside here. But you could have defined technically anywhere. Okay, so does this make sense how it is wiring, all these things are wiring up? Or do you want me to go through again this? Yeah. Oh, okay.
yeah, again.
Is there a question or?
Yeah, she said to do it again, like go over it again.
Again?
Yeah,
the whole
so,
thing? Okay.
Yeah, what in particular? You can
Okay.
do this.
Maybe like after the after I eat, like I lost my focus. This consideration is like something kind of like implementation using this part, or is it like other feature? I just like I'm lost from this.
let me go through this again. Okay. I told you about hold and freeze before, right? Now you can go in even above abstraction. You don't even need to care about hold or frozen. On your palette level, this is your palette. On your palette level, you are saying that this palette requires some consideration for some storage, like accounts will use some storage. And for that, we need to consider how much fees we should charge. So this case is only when you want to charge, if you want to rent some fees for the storage taken by the account, right? Only in these cases. So you're on the palette level, you're just saying, okay, I need to consider something based on some footprint, okay? What it is, how it will work is kind of set on the runtime level, okay? So again, this is palette code. You're just saying it's some consideration, and the actual consideration is here. You're saying, okay, this consideration should be whole consideration. This is the runtime code. We are saying palette pre-image config. Oh, okay. Let's see if I run out of time first or my battery runs out first. And here you're saying it's a whole consideration. What is the reason? What kind of formula to use? So I showed you linear, but I think there is one more constant storage price. And you can create your own implementation of this. What's the trait? Convert. Yeah. So you're just converting footprint to balance. Right? And so this constant storage price just gets some price, whatever you pass it. It's like a constant fee all the time. Doesn't matter if the footprint increases. Now that we have this, how do we use this? So let's see how this palette uses it. Consideration. So at some point, somebody does something, some request, they put probably some blob. Where is this length? Yeah, something. You can look at the exact code, what's happening. And so what you do is you take this type, you call this new, you say what is the footprint, and this returns you some ticket, some object that you need to keep hold of, okay? And this guy takes this and keeps it in storage. And let's see if it's doing anything else with consideration. No, nothing else. So it only creates new considerations. And then I guess when they remove whatever blob they have put in the state, there should be some, yeah. So do unknown pre-image. So they are removing the pre-image. They take this ticket from storage, I hope. Yeah, so this is getting, yeah. This is a storage item, request status for. From there, you're getting that ticket and you're just dropping it. And this will take care of everything. So when you set new, it will do some hold. When you say drop, it will remove that hold. You don't need to care or mutate or do things by yourself. It's basically just a higher level abstraction. So in cases where you want to rent for the storage, this is a great thing to use. Okay?
Is that clear, like when you would use this? Nice.
Okay, last 10 minutes. Is there anything you wish to see? Any palette? Multisig? Okay. You can look at all the documentation yourself as well, but let's look at cool things. Let's say calls, right? So yeah, already you can see this. The wait function is interesting. It's doing multiple things. It's adding multiple weights as okay, maybe this is not the first, so there should be like more. Oops, sorry. As multi. What's this? Approve as multi. I'm just looking over all the calls it has. Cancel as multi. Poke deposit. Okay. Let's look at one of them. Register approval for a dispatch to be made from deterministic composite account if approved by a total of. Yeah. So this is approval. This is as multi. Okay, let's look at this. Immediately dispatch a multi-signature call using a single approval for the call. How do you create it the first time? Yeah, okay, this is how you do it. So, okay. So you say approve as multi. Okay, register approval for dispatch will be made for deposit will be reserved if this is the first approval plus threshold. So this is stateless. So you have no state for this multi-sig. Let's see. Does it have any pallet storage? There is a multi-sig. There's a set of multi-sig operations.
Yeah, so you only keep the operations. You don't keep the object, like the multi-sig object.
Yeah,
That's totally off chain.
right. And what are operations?
Like I propose that we vote on something, and that's an operation. Like the
Mhm.
call hash would be an operation.
So approve as multi would be the first call I would like to make, and then other people will sign the
Yeah,
same thing.
other people will do the same thing, and because it was created, it will go there and like increase the count, and then at some point you dispatch it.
Yeah. So let's see this code. You do some ensure sign. Again, you get this signer of the extrinsic. Max signs, again, these are parameters. You do some validation checks and you want to fail as soon as something does not line up, right? So this ensure is something you will see a lot. Basically, this basically tests this connection, this condition, and if it is not true, it fails. So it checks that this condition should be true. If not, throw this error. You'll see this in a lot of palette code. Okay, again, some validations, signatories, ensure, sorted, and insert. Let's see what's doing. What is this doing? Item and signatories, iter, maybe last. Yeah, so you always sort it. I guess this is probably important. So since it's stateless, if you give different orders of the same accounts, it will generate a new multisig account, which is why you sort it. And so for the same combination, it's always same. Actually, want to see how they generate the multisig account. That would be interesting. Yes, here. Okay, this is fun. What's happening here? So this guy is taking set of account IDs, some threshold, and based on that, it is returning a new account ID, right? How it is doing it, it's some entropy that it takes, some random string. Also, the account, the set of accounts, some threshold, takes all this and uses something called using encoded. Let's see. Okay, so what I believe what is happening is it takes this, it hashes it with this cryptography, right? And then what you do, you take this entropy, you do this trailing zero input. So I think what it does, let's see the documentation. So imagine from the some random bytes that you generate, it's not filling the whole account ID, right? So you fill the rest of the stuff with zeros. Right? And this will give you, this will decode into some account ID. So this is something you can refer how to generate a unique account ID. Right? Okay, it did create this ID. What else it does? Call using encoded. So now it's interesting. So it got a call as part of the multisig call that it wants to make with these signatories, right? So it's now taking the call, some things it's doing with it, and it dispatching it. But it should not dispatch before all the signatories are there, right? Ah, it's multi-threshold one. But then what's the point of it? Immediately dispatch a multi-signature call using single approval from the caller. Okay. I don't know what's the use case. Do you know what's the use case?
No idea.
Question? Is this like whenever we have a transaction and we are waiting for the rest of the signer to approve, in order to have it match the required threshold? So like we are doing it on chain, everything on chain as a transaction.
Sorry.
I just the function which we are checking now. This is
Yeah.
where I want to
The
pass
account
a
generation-
transaction to be signed by the other voters, like the other signers.
Yeah, that's how it should be, right? You need to sign the same runtime call. So let's see something else with a big.
So my question is everything is on chain here.
I mean, signed as in they are signing this transaction. One of the signs of, yeah, so let's say this as multi, this sounds better. So they will sign this transaction and they will pass the call. So whole thing will be signed by them. Not just this call that needs to be dispatched, but the whole as multi probably. I'm hoping as multi is what we want. Let's look at the documentation again. Registered approval for a dispatch to be made from a deterministic composite account if approved by a total of threshold -1 of other signatories. Yeah, okay, this is promising. You have a threshold, you have some time points of the first approval. Then this must, yeah, so first approval, this is none. If it is not the first, then it will be some. The time point, block number, and transaction index. Okay, let's see the function call. As multi, ensure signed, operate. Yeah, I think my 3%. Okay, slowing down. Okay, quickly. Some validation, some multi-account ID. It got the ID. What it does it with the ID? It says is it call or hash. If it's a call, then it returns this, and then what? Whether it's already started or not, so I think it will store it in the multisig, this thing. And next time, if it's the second time or third time, it will go to this. It will check if the time point exists. It will check for the approval. If it is approved, probably it will dispatch it. Let's see. Yeah, here it's doing something. Here, it dispatches it. Removes it because now it's done with this operation. It removes the deposit. It dispatches it. And if it's the first time, it should insert in the multisig. Yeah? And you can see this is where, like these are the old currency trades that we use. It's kind of similar with like holds, but yeah, don't use this. Any other doubt, like how storage maps you should use, or yeah, I don't know. Anything else you want to see? I think probably my battery will die, to be honest. But let's see. Is there anything still like you can't make sense of it or something? A lot of things? Really?
Like in general, because
Okay.
we
But
just introduced all these kind of things, so like a lot.
Have you guys started already coding? Oh yeah, sorry.
I have a question about the multi-sig storage because it's a multi-map. And can you show it,
Yes.
like how it's implemented?
So it's a storage double map, account ID, and some random bytes.
Okay, so why it's, for example, using concat instead of just like Blake to 128? Why with concat?
Here?
Yeah, for hash.
Yes. So yeah, that's a good question. Actually, some places we commented why it is like that. So we said that we should never use this 2x60. I mean, it's not like never. We should never use it if the key is not gonna it's not gonna be secure hash. So as in like it will not be randomly distributed. This account ID is already a random distributed hash. You cannot create account IDs and create like unbalanced tries, right? So for this case, for when you have key as the account ID, you will see a lot of places where you have 2x64 concat because yeah, it doesn't matter. It's already balanced.
Okay, so if I understand it correctly, so it will take the account ID, hash it with the 2x64, and then add it at the end account ID.
Yes.
Okay.
Yes. And that add thing is the internal knowledge, but what it uses is somehow get the key. And so you have nice APIs to get that key. You don't have to care about
And for more clarification, so it's like the account ID and the U832, which is like a hash as well, hash size. It's the total key to the multi-sig value.
Exactly. So this is
Okay.
key 1. This is key 2. And you can see that now for this, it uses Blake 2 because this can be whatever, right? Let's see how it inserts it, right? Call hash. Yeah. So it's basically encoding it already. It actually does it with Blake 256. So maybe it didn't need it, but yeah. Maybe just defensive programming.
No,
But-
there is like all the second option where is
Yeah. Yeah, exactly. So where is, yeah. So this is coming from the call itself. Yeah, that's why. So this can be whatever, exactly. So for the hash cases, this will be a attack. Yeah, it's fun, right? You figure out so many things looking at the code. Okay. We are actually over time. Okay.
The question here,
Yes, yes.
if you open the function called cancel as multi, line 516, I'm just wondering, like the get one, which is in line 532, like this kind of composite key, because like I'm trying like to understand like the ID first, how they are able like to get the ID. I'm just like confused.
So what's your question like?
Like in line 532,
Yeah.
the ID and call hash, is it a composite key? Like we are getting it like in a composite key way, or because like I get should pass key, correct?
But it's a double map, double storage map.
Uh-huh.
So again, if you look, this is a storage double map, which means it has key 1 and key 2. So the key 1 is ID, the account ID that we generate, and the key 2 is some hash. If it was a storage map, you would do just one key. Yeah.
I have another question. So, for example, if we get to this line of code, right, and we already starting to dig into the storage, and then we, for example, the when is not equal the time point, and we exit, we still pay some fee, right? We pay
Still
fee.
pay, yes.
Okay.
So yeah, this is the dispatch result. So I'll tell you what happens. This is the worst case way that you set on the top, okay? And when a transaction extrinsic comes in pre-dispatch phase, you take this balance. And some functions have, this one doesn't, but some functions have this dispatch result with post info. And there, you can decide, okay, we didn't do as much computation as we thought. And so you can reduce it and say, okay, this much was, this should be the fee, right? Or you can actually say, you don't have to pay. You can have free transactions depending on only some conditions. So, you protect from DDoS. And then that worst case weight will get refunded before the transaction ends, right? So overall, you pay some fee, but it doesn't have to be this first fee that we put.
Beginner question?
Yeah.
Like, it's like set question here. It's just absolute beginner question. How can I get the access to the implementation of any function here without enabling the Rust analyzer? Because it kills the
Without
function.
any link to?
The Rust analyzer. I know, I can.
Yeah. So
I have to.
I just want to say, I use, so now you see, for me, it's working decently. Like, I can go to anywhere. For me, Rust Rover works pretty well, but it also can, get very heavy. Rust Analyzer starts panicking with all the macro recursion that we do. Yeah, I don't know the best way. So I know that some people, what they do is they create their own pattern. They switch off the Rust Analyzer. They created their own patterns to search. So you will search struct something, some pattern matching, and do like that. But do you want me to kick me off? Or?
Yeah.
Okay.
Sorry, I can. We have another class after this.
Yes, sir.
Thanks.